pentane has 5 carbons, with most of the hydrogens not shown here. Removal of a terminal hydrogen leaves a location where the rest of the molecule can be attached. This is called pentyl. There are a number of different arrangements of the 5-carbon pentyl unit. To start with, we'll look at variation in the position of just one carbon. Let's remove one carbon from the end. Now, where shall we put it back? We could put it back where it came from, on the new terminal blue carbon. This is N-pentyl, N again representing normal. Next, we could return the carbon one carbon in from the blue terminal carbon. This is called I-pentyl, where it represents iso. Continuing on, we could also return the carbon one carbon in from the attachment. This is described as S-pentyl, where S indicates sec. Variation can exist in not just one, but 2 of the pentyl carbons. Now we're going to remove 2 carbons and relocate them. But where should we place them? We could be returning them one carbon in from the terminal blue carbon. This is described as neo-pentyl. An alternative would be their relocation one carbon in from the attachment. This is known as T-pentyl, where again T stands for tert. So once more in summary, iso and neo are one carbon in from the blue terminal carbon, and sec as well as tert are one carbon in from the attachment. Iso and sec relocate one carbon, while neo and tert relocate 2 carbons. Iso, sec, neo and tert, propyl, butyl and pentyl, where applicable in 1993 were preferred IUPAC, that's the International Union of Pure and Applied Chemists, nomenclature. So they should have been used to meet the strict IUPAC name. But since the rule change in 2013, they have been downgraded to only general IUPAC nomenclature. So you can use the term and everybody understands it still, and indeed they often are the most commonly used terms, which is why I want you to be aware of them. In general usage, propyl and butyl are much more commonly described with iso, sec and tert when compared to pentyl. Hexyl and upwards are not described as iso, sec, neo, nor tert. However, except for tert butyl, none of these terms should be used if you need to follow all IUPAC name rules. They should be treated as uncommon or complex alkyl substituents when it comes to naming. Now, only tert butyl can be used in the preferred IUPAC name, or PIN. This again shows how IUPAC rules evolve to attempt to reflect trends in usage by the chemical community. I'm not sure they always succeed and may sometimes support unpopular positions. However, a drive towards more systematic rules is, I think, generally a good thing.